What?
So there's just a lot of coffee.
Oh, yeah, could be. Okay, so section 3.5. We start out, and we'd like to have the screen. Okay, perfect. All right, so we start out with a couple of trig function derivative rules. The derivative of sine x is cosine x. So here's a couple of examples. Y equals x squared minus sine x. Maybe I need to make that a little bigger. So here's the original thing. Well, y prime is, take the derivative of that piece, so that's 2x, minus the derivative of sine x, which is cosine x. So that's not bad. Okay? All right. This one, however, y equals e to the x sine x. You have to recognize that that's a product. E to the x sine x is a product, so you have to use that product rule. Here's the roadmap. E to the x times the derivative of sine x plus sine x times the derivative of e to the x. So we know when we do it that way, we're only taking the derivative there and the derivative there. So your next step would be e to the x times cosine x plus sine x e to the x. You could factor out the e to the x and be left with this. Does that make sense? Good. This example, sine x over x, is a quotient. Okay? So again, we've got to use that roadmap. The bottom times the derivative of the top minus, and I usually put it in brackets to keep all that stuff over there, the top times the derivative of the bottom, all over the bottom squared. Okay? Derivative of sine x is cosine x. Derivative of x is what? 1. So we've got x cosine x minus sine x over x squared. On a lot of these, there's not a lot of cleaning up you can do. Okay? So you leave it with those kinds of answers. All right, questions on those? Yes?
And it won't pull up the lecture notes. Like, I click the lecture notes button, and all this is a problem set again. It's just the 3.5 problem set.
On 3.5? I'll look at it. I will, because I did fix something, and so I don't know. I'll look at that, and I will repost for sure. All right. Scroll up. Okay. Is that good? And again, when you test on this kind of stuff, you want to see that work. I don't want to just see the answer so that I can kind of trace back and see where you missed it. Maybe it was just an arithmetic error or something and you could get partial credit. If you have nothing there, then it's wrong if you miss it. Okay. All right. Are you good now? Okay. All right. So now the derivative of cosine is negative sine. So they are just kind of opposite of each other, except with cosine you get a negative in there. And if you don't remember that, you're going to be messed up on your answers. So we got some examples of those. 5e to the x plus cosine x. So that's just 5e to the x minus sine x. Okay.
So when you take the derivative of e to the x, the only thing, it stays the same unless there's something up there with it?
Right. If this had been 5e to the 3x, then it would be 5e to the 3x times the derivative of that, which is 3. So it would be 15e to the 3x. Okay. On that formula sheet, I don't know, I don't have one right here, but I think on e to the u, yeah, somewhere. Which one is it, if somebody finds it before me?
It's like the 10th one, number 10.
10? Okay, so e to the u is e to the u times u prime, whatever u is. Thank you. It's why I like that sheet. It reminds you about that issue of having to take the derivative of the argument. Okay. All right, then sine x, cosine x, that's a product. So it's really helpful if you do the roadmap. If you don't need it, that's fine. Just be careful. sine x times the derivative of cosine x plus cosine x times the derivative of sine. You end up with sine times negative sine plus cosine times cosine. Negative sine squared x plus cosine squared x. And you could put it in this way and MATLAB would take it, but convention just says usually we let the positive thing be first. That's the only thing that goes there. But I think it would probably take it. Okay. All right, and again, quotient. This one had some algebra stuff and some other trig stuff going on in it, so let's kind of look through this. Bottom times the derivative of the top minus the top times derivative of the bottom over the bottom squared. So I've got 1 minus sine x times minus sine x minus cosine x times negative cosine x because that minus is there. Okay, everybody good? All over that squared. So here when you distribute, that's what happens here. This gets distributed here. So negative sine x plus sine squared x plus, how did I get this? This is being multiplied, so this is negative cosine squared x times a negative. So we get plus cosine squared x. You need to remember, and this is from Trig, what does that equal? 1. So that's what I've got written out to the side. That's one of those identities. Sine squared plus cosine squared equals 1. Yes, ma'am?
Why is that sign negative?
This one,
The one on top that you distributed?
right here, because it was the derivative of cosine, which is negative sine. Yeah. Question?
Yeah, about the one before that, we can use.
Up here?
So can you replace the cosine or the sine with the cosine minus 1 or whatever?
Could you make this 1 minus sine squared, and so then you'd have 1 minus 2 sine squared? You could. I don't think it makes much difference here. Like terms, yeah, but absolutely you could do that, and that might come in handy sometime. Yeah. Okay, so we did that, and so now we have 1 minus sine x over 1 minus sine x squared. So one of those gets canceled out, and we have 1 over 1 minus sine x. Okay? That's really important that you remember that. So that's a yellow star. That doesn't really mean much. Okay? Questions? Are we good? Want to start the problems? Okay, I like that. Shoot, yeah. All right. Okay. Okay. Find the derivative of y equals 2x plus 5 cosine x. Okay. Did I? Was there? Hold on. Up here. I think, yeah. I did have this on the notes as well, but you've got that formula sheet now. But there's those other 4 that will print on there if you print that out. Sorry. Okay. All right. So what do we get here? What's the derivative of 2x? 2 plus 5. What's the derivative of cosine x? Okay. So it would just be this. You pray for something that easy on the test. Okay? You just do that.
Does it matter if we distribute the negative to plus?
Say your question again. Are you asking if you should distribute it here?
Like, no, does it matter that you took the negative and put it in between the 2 and 5?
Well, you are multiplying 5 times this, so if you remove the parentheses, that negative has to be there. Okay. All right. Okay. It's all right. You're on the video now. Thanks, Coach. Do you want a piece of pizza on the way out? Okay. Looks like enough. All right. So we're finding dy dx for x to the fourth sine x. What do we know about this thing? It's a product. Okay? So we got x to the fourth times the derivative of sine x plus sine x times the derivative, and I'm going to run out of room, of x to the fourth. Okay. X to the fourth times what? Okay, plus sine x times, okay, and then we'll kind of clean that up. Can't do much. X to the fourth cosine x plus, do they put it first? Okay, and which one matches that? Here, different order, but it's the same thing, I think. Okay. All right, so we're good? Okay. Now you may have to refer to your sheet because we haven't been using tan, but this again is a product. So 3 cosine x times the derivative of tan plus tan x times derivative of 3 cosine x. Make sense? Okay. What's the derivative of tan?
Secant squared.
Secant squared. So we got 3 cosine x secant squared x plus tan x. What's the derivative of cosine? Negative sine. So let's clean that up. Secant squared x minus 3 sine x tan x. Is that one of our answers? Of course not. Oh, so we probably need to do some identity stuff. Yeah. Okay. Could we change this secant squared to anything? 1 over, who said that? 1 over cosine squared? Okay. Minus, can we change tan x to what? Sine over cosine.
I think it's B. So I think
It's not B. I don't think so. But, you know, I could be wrong. All right, so what happens here? What would this become?
Just 3 cosine x.
3 over cosine x. All right, minus, what do we got here?
3 over cosine.
3
Well,
sine squared x.
yeah.
Over cosine x. Over.
Okay. And since these denominators are in cosine, can we change sine squared to something? What was that rule that I said was really important a minute ago?
It's to cut 1 minus cosine squared.
So what would sine squared equal? 1 minus cosine squared? So let's see if that helps. 3 over cosine x minus 3 times 1 minus cosine squared x over cosine x. What? Okay. Now, this is the same denominator, so we can really combine the tops, right? 3 minus 3 plus 3 cosine squared x over cosine. Is that right?
Yes.
Okay. These are gone. And one of those can go away. So, bam, bam. What's our answer?
3 cosine x.
3 cosine x. Maybe when you started that problem on your homework, if we had not done this problem, you might not have thought about that. But you wouldn't find one of those other answers. So there's enough, you've got to learn to do some substitutions. And with it being multiple choice, you have some places to shoot for. Okay? Questions? Anybody still writing? Okay. Here's one. Why don't we try this? We've done products, and you've got your sheet. Is that the same one?
No, that's just, let's do this.
It's very similar. Is it the same one?
No, it's not. Yeah, it's exactly the same.
I was looking at it thinking, that's the same one. I don't know what happened there. Well, you'd have made me work it again. I'd have figured it out. Okay. All right. Why don't we see about this one?
I don't think we're ready to do this on
Maybe? Not ready to do this one? Well, let's try. You're okay with not trying? This one was kind of crazy. Okay, the technique here that I looked at was secant squared is like secant times secant, right? So that's like a product, tan times tan. So I did two derivatives that are products, okay? I don't know what that is.
What's
The problem?
Yeah.
Sorry. And where did this come from? Where did secant squared minus tan squared come from? If you multiply these two, that's what you get. Okay? Because if you look on your sheet, I think you I don't know that this thing's being multiplied. So it would get kind of ugly. This is going to help you work through it. It's ugly enough as it is. But it would be hard to do this the way it is. So, multiply that out, and then you've got this, and we've got the 4 is going to get distributed to both places, so I kind of ignored it at the first. So I've got secant times the derivative of secant plus secant times what? I did it, yes. Okay, it looked horrible. It's the same thing, but I did it. It's all the same. You need to write it out so that it makes sense. So secant times secant tan plus secant times secant tan. You're getting the same thing. Does that make sense? No? Sort of?
Yeah, because
Well, we're just doing this part right now. That's all we're doing. We'll do this part in a minute. So when you do that, you get secant squared x tan x. That's distributing. And you get it twice. So you have 2 of those. All of that's the derivative of this piece. Yes, ma'am?
How do you know where to start?
Well, I'm trying to show you several ideas of things to do. Can I give you an absolute that you do this every time? No. It's practice, and it's thoughtfulness that this original thing would be difficult because that's a product. Sometimes it's better to go ahead and multiply those things out before you start. So that might be a good tip. Go ahead and multiply if you have things that would multiply okay, and especially if it looks like it might simplify it. So in this problem, that's one tip that I would give you. Go ahead and multiply first. And then we're just taking the derivatives separately. All right.
So when you distribute secant x through, why don't you multiply it by tan?
Well, you're still multiplying by tan.
So you
see what I'm saying?
You just do it by secant x and make it square.
Well, because I'm multiplying here. Secant is getting multiplied by tan right here. So I don't have to write it again. Does that make sense?
Yeah.
So
you're saying. That's secant squared. So you put secant times
tan.
secant times
If
tan.
you're thinking of maybe if it were secant plus tan, then you would have to do separately.
Oh.
But this is already multiplied, so when I multiply the secant times that, it's just like I'm attaching it. And when I attach it to that guy, I get secant squared, and I'm still multiplying by tan. Does that make sense?
Yeah.
Okay. All right, so we've got that, and then we do that second part, same way. Derivative of tan is secant squared. So I've got tan times secant squared plus tan times secant squared. And so I have two of those. Aren't those the same thing?
Yes.
And we were subtracting them. When you subtract them, the answer is 0. Is this multiple choice? No? Oh, so we just have to get the answer on this one.
When you do it the negative,
What negative?
when-
Up top?
Yeah.
Well, that's why I said, no, when you subtract them, I did it in two pieces, but it's this piece minus this piece, so it's the yellow minus the blue, and they cancel each other out, and you get 0. I just didn't write it again. Okay. Does that part make sense? As much as any of it? Sort of.
That's one of the parties.
Two of those, they cancel each other out.
That was a D.
Yeah, it was fun. All right. Try this one. It's not so bad. 2 cotan t minus e to the negative 1. Can you see that? I'm trying not to. Let me make it big. Two cotan t minus e to the negative 1. You've got your sheet. Remember e to the u, because this is not a plane thing. This is e to the negative t. So you got something going on there. And do the cotan thing. Let's see what we get.
That's a T.
Mm-hmm.
And
Oh, is that to the 1? Was that a negative t?
I think it's a negative.
Yeah.
I think, did I work it that way? It's okay. I do. I do. Yeah, that's not a negative 1. That's a negative t. So sorry. Here's what it is.
Should have that in mind.
That's what it is.
ET.
ET. Phone home. So it's really, you don't have a product or anything. This should be fairly simple, just looking at the thing. What is the derivative of cotan?
Negative cosecant.
So 2 times negative cosecant squared t minus, when you do e to the u, you have e to the negative t times, what's the derivative of negative t? Negative 1. So we have negative 2 cosecant squared t plus e to the negative t. That one wasn't too bad, really, if you've got the reference sheet. Okay. Are we good? Okay. Oh, I think I have it
How do
worked.
you get the derivative from the E with the,
Do what?
with the E or something other than just X?
Yeah, it's something other. If that had just been e to the t, then your answer derivative would be e to the
But
t.
how did you get that? I was trying to remember that last night, and I couldn't remember how we got it.
How that rule works? Well, on your sheet where it says the derivative of e to the u is equal to the e to the u times u prime, meaning you take the derivative of that thing as well, of whatever you're raising the power to. So if you have e to the negative t, the derivative of negative t is just negative 1.
So
If it had been e to the 5t, what would your derivative be? E to the 5t times what? 5. Whatever that is, that's your argument. You have to take the derivative of that and multiply it by the original.
You know, this one got a superscript in the next line.
Do what?
Don't change anything about
No,
the exponent.
not when you write it originally. Drew, is that good? I mean, that rule is just the rule. And so, what if you had e to the 5x plus 2x squared? What would be the derivative? It'd be e to the 5x plus 2x squared. You always write the original times 5 plus 4x. Do you see that? That's the derivative of that. Okay, so whatever that thing is,
the derivative of the superscript.
and we'll call it the argument. Yeah, yeah.
So, like what we just did, cosine squared t, you're supposed to multiply it by u prime, which is 1, and you just don't show that thing?
Right, right. If it's just 1, it's not a big deal. Yeah, it's only if it's something that's going to have something more. Okay? All right. Okay, what is this? What is this guy? Quotient. So this is going to require a big road map. Coffee. Yeah.
That's actually cold.
Sorry. It is a multiple choice question. And so I'm going to go ahead and tell you the answers here, but you need to work for it. Work towards it and see if you can come up with that. Okay? Bottom times the derivative of the top plus top times the derivative of the bottom over the bottom squared. There's the road map, I think. So you're only taking the derivative here and here. It's the only place you actually have to take the derivative.
It really wasn't that bad, actually.
It just looks ugly, doesn't it?
It's hideous.
I don't know if I can get it all on there. So this part's just the road map. This is where I took the derivative of that. So this was the derivative of this guy. And this was the derivative of that one. And then it was distributing. So that was your algebra. Multiplying this thing by both of those. things canceled out, and there wasn't a lot you could do after that. See if that makes sense.
I hate when they give you a variable of t and there's a digit involved.
It's especially bad for me because mine look just like the little pluses. Sometimes when I work it, I go ahead and change it to x's, and then in the answer I'll write it back in t's or something.
Because like that first part, you have, in my mind, I see -2 cosec, and then you t.
Right here?
Yeah, right at the beginning.
Yeah, that looks really bad. Sorry. Well, and 2, things should be in parentheses and weird, I don't know. Just ignore it. Play like I wrote x's.
Oh no, yours is fine. It's just on mine.
Yeah. No, mine's bad too. Mine's bad too. Is that making sense? You're not going to, you don't maybe know at this point what the derivative of cosecant is, but you should be able to find it on the sheet and then plug in. The rest of that, beyond this line, is algebra. And I'll say again, the calculus rules, you can do those. It's the algebra that will kind of do you in sometimes. Okay?
Where does the 2 go in the blue for the first one?
Up here, the derivative of 2 is 0. Yeah, it was a constant. Any other questions on this one? Pretty good? Keep on going? Okay. I like that.
Will we ever have to,
Yes.
the square, you'll have to, FOIL it and then,
The only time that might come up would be, I would say, if it was something different up here and you factored out a piece, and I think we have one like that maybe in the next section, and then one of them can get canceled out with one of these or something. Usually you don't multiply it out, but sometimes since you have 2 of those, one might cancel out with some, algebraically. And again, if you got down here and you didn't do that final simplifying, it's certainly not going to be wrong for me. Might be a point off for not totally simplifying. The thing with Math Lab, you got to get it where they think it should be. Okay? Which is good practice. It is good practice. All right. Let me go back over here where I don't have it worked. Is it this one? Are we on 7? Okay, write that down. Find dr d theta if r equals 3 minus theta to the 5th sine theta.
That's really easy on those algebras.
No. Theta. So what is this? Because theta is your variable. Product. That's a product.
so the 3 just goes away?
Yeah, when you take the derivative of that, that's gone. But you do have to worry about this. Okay? So work that as a product. Theta to the 5th, sine theta. It's really not bad. It's really fairly clean. So that would be your roadmap, if you can read it.
But it's the negatives in front of,
That was from there.
but you didn't put it in the derivative of theta to the 5th. You left out the negative. When you're taking the derivative of theta to the 5th, it's supposed to be negative, isn't it?
I think this minus is just really just out there. You can just have that at the end and think of this. I had that at the end because let's just do that. And then at the end, we'll put in a minus. I don't think you have to do it
You
all
don't have to
places.
put it through
I don't think
negative
so.
derivative.
Because this is really just subtracting that, and if we subtract it at the end when we get our answer, I think we're good.
Okay.
Let's try that. So what do we... Actually,
Do you see them?
I do see what you mean, and you may...
Three's going.
But we can do it at the end, but you are going to be right. It is going to be negative both places. What I'm thinking is we can do this. Now we can do all of that. So we have theta to the fifth cosine theta plus 5 theta to the fourth sine theta. And then it's all negative. So if we wrote it without the parentheses, we would have a negative there and a negative there. Does that make sense? I was trying to do it all at once, but your way would have worked as well. It really wasn't that bad, was it? Not really. Yeah, that one was much, much worse. Okay. So we good? Are they getting better? As much better as they could get. Okay. Next one's easy. Here's a suggestion. And Dinah, you were saying, how do you know where to start and everything? If you have this, you want to think about reciprocal relationships for trig. 1 over tan is the same as what? Cotan. 1 over tan is the same as cotan. Then we wouldn't have a fraction. We wouldn't have a quotient thing there. So I would rewrite this guy as 2 plus cotan q. And then I would take the derivative. And what's the derivative of cotan? Okay, so negative cosecant squared q. So right there. That just makes it really easy if you can rewrite it sometimes.
So like all those are points of direct derivative.
Okay, this one looks like it might not be quite as simple. I think there's a good bit of algebra going on here. This would be really good to practice. So we've got a quotient, and what do we got up here? We have a product. So within the quotient roadmap, you got a product. That's just mean, isn't it? It's just mean. Sorry. Just wrong. Yeah, it does take a lot of paper. Okay, we'll write it down, and then I'm going to scroll up so I can write as well. So 4q sine q over q cubed minus 2. And I'll just walk around and see how your progress is going with that. Of the bottom all over the bottom square.
And I literally wrote the rule with those words, bottom times derivative of the top. And so every time you write the roadmap, you almost have to say it in your head. So try that.
So then you have to find the derivative of that product in order to use it.
The derivative of the product, then you find the derivative of that, and to do the second part of it, the division of the quotient.
So do you have to take the derivative of the top twice
Yeah, that's
in the
what
process?
Well,
like once you find the top, you take the derivative of that to solve the quotient.
well, the derivative of this is a product, and within that product, you're going to be taking two little derivatives, right? You're going to be taking the derivative, this times the derivative of that, plus that times the derivative of that. Does that make sense? No? I love that. That honesty is great. Let me move up to the next step. So here, 4q times the derivative of sine is cosine q, plus 4, because that's the derivative of 4q times sine q. So that whole thing there is the derivative of that product.
And then I'm asking if you take the derivative of that when solving the quotient.
Because you've written it all out. This is part of, because you did this times the derivative of that, which we just did, minus the top times the derivative. What did I do? The derivative of this. Yeah, I think you're trying to take the derivative one too many times. Yeah.
See, I didn't write the whole, I do it in parts.
Yeah.
Instead of writing.
For me, and you have to do it the way it works for you, but for me, I like to do the roadmap. If I don't do that, I get kind of caught up as to where I'm doing derivatives, where I'm not. And so for me, it's always worked that way. But you will find the way that works for you. Okay? But just getting the roadmap's a good start.
What's the original?
4q sine q over q
Boy, sad boy. When you're 4, many years ago, you inherited that story. Interesting story.
That's that. Yes. Okay. Well, if you left out, see, you have to do the quotient first. That supersedes, and then within that, you're going to do that.
Okay, so I can't do quotient on that.
Yeah.
I don't know, I was just celebrating.
All right, let me move up a little bit more. There's a lot of algebra going on. And rather than just copying that down, you just keep working and see if you get, here's the final answer. that's where you went. Okay, did some of us get it? Were you getting it before that work was up there, or did it take the work?
I got it about halfway, and then I didn't know that you had to distribute the cube minus 2 through it.
Yeah. What I would say about this kind of problem on the test, it's going to require me looking for far more than just the answer. Because there may be some, maybe you didn't simplify it quite the way I did. I'm interested in the process as much as the answer. So the more work you show, as long as it's good work, the better chance you stand of getting credit on those. But with these kinds of problems, there's just a lot of work to show and a lot of work to grade. Okay? So just keep that in mind. Sometimes people want a shortcut. They don't want to write a roadmap. That's your choice. But I think it's helpful. It's the way I've always taught it. It's the way I do it. And I don't do it in my head. And you've seen, I make plenty of mistakes. So you don't want to do that. All right. Any questions on that one? Yeah, I'll leave it up. Are you lost? But hang in there. Hang in there. All right. Can I move now? Everybody good? All right. Okay. Let's kind of go back here. All right. What is this asking us to do? Double prime. So it's a pretty easy thing, but we've got to do the second derivative as well as the first derivative. What's the derivative of cosecant? Look on your sheet. Okay, so the derivative of cosecant is negative cosecant x cotan x. Okay, so that's what we got to remember. So what do we get? We get 4, negative 4, cosecant x cotan x. That's y prime. Now we've got to take the derivative of that, and what is this? It's a product now. So we have to go from there. And by we, I mean you. Okay? It's really a couple of steps, so it should be okay. So there's the roadmap up there. But at this point, I would hope that we're kind of getting okay with doing that.
So right there, you just multiply cotan x by cotan x and have cotan squared x.
Mm-hmm. Mm-hmm. That's what you should do. And what would you get here? Algebraically, what's happening here?
be
cube x.
Mm-hmm.
Well, also 4.
Yep. Knew that? I think that's it. This one over here. Hmm.
There's the derivative of negative 4, so it turns out to be positive.
What's the derivative of cosecant? Is it negative?
Negative cosecant.
Is it negative cosecant? And so the negative times that. So it became positive. Does that make sense? You were right. It is a negative, but you've got two negatives. Okay. Is that good? That one wasn't too bad. Okay. Okay. Whoop. Sorry. Okay. Now we get to think a little bit. Your favorite pastime. Let's make it a little bigger. Okay. Find the equation of the tangents. And so when they ask you that, what do you know you're going to have to do? Take the derivative of something to the curve y equals sine x. So here's our function at x equals negative pi, 0, and 3 pi over 2. Graph the curve over that interval together with the tangents and label each curve and tangent. Of course, you're going to be doing this on Math Lab, so you're not going to do that. Okay, so first of all, we need to take the derivative of this curve. So what's the derivative? So I would somewhere just write that. Cosine x, okay? And so if they've given you points, it wants to know the tangent at those points. So you need to know what's cosine of negative pi, what's cosine of 0, and what's cosine of 3 pi over 2. Okay? If you don't have those memorized, I totally get that. Think about the unit circle. Maybe I can go over here a little bit. Okay? And remember that if you went over 1, this point is 1, 0. This point 0, 1, negative 1, 0, and 0, negative 1. And which number's first on the unit circle, cosine or sine? Cosine's first. So the values at 0, here's 0. Maybe I need to do that in another color. Here's 0. Here's pi over 2. Here's negative pi. Not negative pi. It will be negative pi. Never mind. And this will be 3 pi over 2. So you can pull out the values of cosine if you can remember that, or at least picture that in your mind. So what's when cosine of negative pi is going to be what? Negative 1. Cosine of 0?
1.
And cosine of 3 pi over 2? 0. Okay, so if you didn't have a sheet and you didn't remember those,
Let's do 0.
okay. Weird. Okay, so if you didn't remember them, you could do this in your head. I do that all the time because I don't have everything memorized about that unit circle, but I can get in my mind 1 and then 0, 1 and negative 1. I can do that in my head, or I can draw it. So that's something you might do. All right. So this is what the slope is at that place. Isn't that what the tangent does? Okay. So we have a point. How are we going to write the tangent, the equation of the tangent line? We have an x value. Here's our x value. Here's a y value. So these are points. Negative pi, comma, negative 1. 0, comma, 1. And 3 pi over 2, comma, 0. There's a point. What's our slope? What was our slope? Cosine x? Well, we have to figure out, or these are our slopes. These are our slopes. You do have to figure out what your y values are. What are your y values? I just wrote it wrong. Sorry. Right? Isn't that right? Yeah. Okay. So what's the sign of negative pi? What's the sign of 0? Here's your picture. Okay. And what's the sign of 3 pi over 2? Negative 1. Okay? All right. So if you have a slope and a point, can you write the equation of the line? What would be the equation of the line here?
Y minus 0 equals negative 1, x minus negative 5, or plus 5.
Okay. So that'll be y equals
Negative x minus 5.
write the other two. What will they be? Y equals x. Yeah. Because that's y minus 0 equals 1 times x minus 0. And then how about this guy? So it'll just be y equals negative 1, right? That's the work you have to do for that question. It wasn't a lot of hard stuff. It was remembering the unit circle, kind of, or at least looking at a trig reference sheet to get those.
Can you just plug those into your calculator?
You could. You could. Now, if you plug it in your calculator, just remember that in the equation, you're going to have to write pi out and stuff like that. But you could get the values for sure. You know, you can get cosine of negative pi and that sort of thing. Yeah. And then it said choose the graph below. So you guys need to practice that on your calculator. It said, what all are we graphing? The label each curve. Graph the curve over the interval. So what is this interval? What is that going to be in your calculator? Is that your window, your x-min, and your x-max? So we're going to graph y equals sine x. And the window, we're going to have an x-min at negative 3 pi over 2 and an x max at 2 pi. So let's graph that, and then together with their tangents. You can't see those on the picture up here very closely. You would see them on your and it looks like y min and max are at 2's if you want to try to match this picture. Make it big. In purple, it has the tangents. So if you want to put them in, you're putting in those lines. Y equals negative 1, y equals x, and y equals negative x minus pi. Those are the lines we're also trying to graph. Maybe that's a little too big. Sine x.
So you don't have to graph it, do you? Because you can just look at.
If you can
y
just
equals
tell.
negative 1, so you know the third one's going to be straight across at negative 1.
Right. And do you have anything else that does that?
Y equals x, you know it's going to go through the origin.
That right there was your elimination. I mean, absolutely you could do that. You could say, do I have, maybe they would have had 2 that were something at negative 1, but they don't. So you, in your infinite wisdom, said I can count out those. Okay, because that's the only one that has a horizontal at negative 1, and here's y equals x, and what was the other one? Negative x plus pi or minus pi or something? Okay, so that's what's happening there. So use your astute observation, and maybe you can eliminate things. It is worthwhile to note that those are the tangents to the curve. Okay? Questions? Anybody? Okay. All right. All right, find an equation for the tangent to the curve at P and the horizontal tangent to the curve at Q. All right, here's the original function, because you're going to have to take the derivative of that and then evaluate it at this point. So take the derivative of this. What's the derivative of cotangent? So we have negative cosecant squared x. What's the derivative of cosecant?
Plus, it'd be plus 2 cosecant x tan cotangent.
Bless you. Okay. All right. Now, we have to evaluate this at this point. So when x is pi over 2, what are you going to get for the point? For y prime. What's the slope when x is pi over 2? You got to plug pi over 2 there. Can you do that? Can you do that in your calculator?
Isn't it like
The second.
cosecant is the second sine?
Mm-hmm. Well, it's 1 divided by sine, not second sine. Is that what you're saying? It's 1 divided by sine.
So negative 1 over.
Does anybody have that sheet that I put up as a handout? Or maybe, did I put that sheet up there? That has that nice trig stuff at the bottom?
Yes.
Because that's when you want to have that.
So it'd be negative 1 over sine squared I plus 2. I mean, plus 2 times.
We'll see if somebody comes up with it. Are you looking at my notes, or did you figure that out? It's good. Did you do it in your head?
No.
Did you do it on a calculator? If you do you have it on the calculator?
No, I erased it.
Do second enter and it'll come back.
Doesn't.
Or if you didn't really do it, you could
No, I did it.
own up to that.
I did.
You did it?
Yeah.
But where
I
did you
didn't
do
like
it?
it. I'm sorry.
I was going to use your calculator to show everybody.
I got it.
You got it? Negative 1. You got it?
Errors.
I didn't think you were the first to explain it.
They're not going to have it.
That's fine. I'll use
It's just another years.
Okay. He happens to have a TI-89, which is awesome. Can you move? You just move over.
Yes, ma'am. If you go up, you can scroll over.
He did all that nice work on this lovely calculator, and he did get negative 1. Everybody will be wanting to run by their TI-89. I don't think it's... Yeah. If you're... It's been around long. If you're in engineering, it's a great one to have.
They told, I talked to them, they told me to get the newest one, the Inspire one. They said you can use it in your calculus science and get all the answers. It has, it pretty much gives you like...
That's what this does.
TI-84.
Who else was telling me they needed an engineering thing? It was you. Are y'all allowed to use 89s in engineering?
No.
You don't know?
We haven't really used any calculators
Yeah,
yet.
we haven't.
Somebody in an engineering class told me that they told them to get a calculator.
Yeah, she said that do use the TI-89 ones.
Okay. So be worthwhile because they do so much more. They do so much more. Okay, so let's get back to the question. Y equals -1. Now what are we supposed to do? We're supposed to write the equation on the tangent line. So let's finish that. Okay, how do we write the equation?
Y minus.
What do we do? Y minus 5 equals, what's our slope? This is y prime. So -1 times x minus pi over 2. And let's clean that up as much as we can. That's a really badly made file. Okay, let me move it up a little. Okay, so you took the derivative of the function you were given, then you took the x value you were given of the point, plugged it in, found out what the slope was at that point, and so this is your slope, and then you use the point slope form, y minus the y part of the point equals -1 times x minus the x part. Okay? We good? Okay. Last one. Next last one. Okay. Find the limit of this. Just kind of brought that back for fun. Is there a reason we couldn't direct substitute on this? No? What's that equal?
4 pi.
Well, it's actually sine of that. And what's the sine of 2 pi? Okay. Nice one. Okay. Got to just think. Okay. All right. Last one. Everybody yell hooray. Do what? I know. I kind of got carried away on this one, didn't I? Okay. All right. The equation gives the position. So we got that position thing going on. Find the body's velocity, speed, acceleration, and jerk at time t equals pi over 3. So here's the original. See if you can do this one. It's just taking several derivatives, or the absolute value of a derivative.
Do you know how much the TI-89 was?
All right. What's S prime of this? Yes. -7 cosine t. Okay. What's velocity? Is that the first derivative? Okay. So at t, and that's an equals, pi over 3. You can either use your calculator, except, I don't know if that'll help you. It should. Maybe. You're plugging it into here. Plug it in. I know, it'll die. We'd have to go home if it died. Don't plug it in. Okay. So, what do you get here? What do you get? What's the cosine of 60? 1/2? And so this is negative 7/2. Okay. All right. The speed. What's the speed? Absolute value of that. So we'll have 7/2 here. Okay. Acceleration is what? Second derivative. So S double prime would be what?
7 times 7.
So 7 sine pi over 3. Do you remember what the sine of 60 is?
Square root of 3 over 2.
Square root of 3 over 2. So there you go. Now, if you tried to do sine of 60 on your calculator and it's not an 89, you're not going to get the radicals that it wants in the question.
So the 89 would give you the radical.
He's like, I gotta give me one of those.
Why did I buy this piece of crap?
Okay, the jerk, we're going to use the third derivative. Okay, it's going to, you can get it by doing that. So S triple prime would be what? We're back to there. Okay, and so that's going to be what? Positive 7/2. All right.
So would it always be that the jerk and the speed are the same, or would they be different?
Thinking. It could be different because it just happens with this particular function, this trig function, that you vacillate back and forth between cosine and sine, and you were just off by a negative. But in other functions, that won't be the case. So I would hesitate to say that. Okay, questions? Anybody? You don't have